build scalable applications. Let us not forget that. I would like to keep on repeating it. A reason is that they have committed themselves to bring a very good platform for us, and that platform is going to be useful for building scalable web scale applications and very complicated sophisticated applications like Facebook or in my experience even Twitter or a G plus or even Google News, which is having a lot of feeds from a lot of sources and allows you to share it, allows you to read about your news source, all those things. So those kind of things you can do in Amazon. So let us not forget that. I'm going to explain the Amazon infrastructure now, then we slowly deal into how the services are built into the Amazon infrastructure. We need to know how they are built, how the Amazon world is built in here. So the next one, you might have seen it before, the Amazon global infrastructure. We will start delving into each of them a little bit more now. Each of those orange circles, you must remember that that is a region. A region is a physical location where Amazon is present in the world, and in each region there might be more than one data center. So that is why there is a number there with a hashtag, and that says that whether that region has one data center or two data centers or three data centers. Usually where there is a minimum of two data centers. Okay, thank you. And there is a blue color dots also that you see on your screen. The blue dots are nothing but edge locations where the content is getting distributed. This is mostly for static content or video content. If you are let us say, a movie producer, or somebody wanted to say something. Okay. I was talking about the content. Am I audible to you guys without static? Quick yes or no in the chat window. Okay, great. So again, content distribution networks, if you're a movie producer, or let us say if you have a static website, you can configure it and then you can distribute it all over the world. So let us go ahead and talk about a little bit more on the global infrastructure. And the green dots here that I wanted to show you was the upcoming data centers or upcoming regions. So Amazon keeps on adding new regions. This slide is little dated because the India region is already, I'm talking about this one, this India region is already has gone live, and same way this Beijing region has also gone live. So what I wanted to show is whenever you see a slide like this or any information in the internet about this, and when you see a green icon or a green circle there, and this is the standard way of sharing information. So I don't expect it to change in the coming days also. So whenever you see a green dot, or when you're talking to a customer and a customer asks for a particular location, saying that do we have a data center in, let us say, Africa. So you can go and Google for Amazon global infrastructure and look for this image and say whether there is a green circle or if there's an orange circle. Then you can tell your customer saying, yes, we have a data center, or we are Amazon is going to have a data center in the coming time. So that is how you read this image when you see it in the internet. There will be text also will be there, but this is a quick way of seeing where all Amazon is present and where all they are going to have a presence in the future as well. So again, this is a pictorial representation of the, where is it? Yeah, here it is. So this is, you see the numbers there, 3, 2, 5, and all those things, especially the 5 here. The Virginia region is one of the first data centers that Amazon built, and that region alone has 5 different data centers. So when I say data centers, each of those 5 data centers are isolated physically, not logically. Let me repeat that. Each of those 5 data centers are physically separated, and each of them are interlinked. So you put a data in one of them, automatically wherever fault tolerance is required, Amazon will copy that to the other data centers. For example, if you're using a storage, S3 storage, Amazon gives you 11 nines of availability for that. So they have to copy it to multiple locations, and they do that by interlinking multiple data centers, and they do that. So let us look a little bit more in detail about the numbers here. let us say it appears for you very clearly. So these are the numbers that I was talking about, the 332. That means there are 3 regions available in the west coast of the United States. And of those 3 regions, each of them, I mean, some of them are having 3 data centers, some of them are having 2 data centers. So if you isolate one of them, this is how it happens in the back end. So they have redundant tier 1 region to region connectivity. That means that the Virginia region on the East Coast as well as on the California region on the West Coast are connected with the tier 1 connectivity, and each of them are on separate floodplains. That means that your data center are not going to be flooded all at the same time. And all the data centers, that is each, let us call it availability zones. That is what the official term Amazon uses for the data center inside your region. So each of these data centers or availability zones are separated by a millisecond separation. That means there is not much of a latency happening between these 2 locations, and there's a peak traffic of about 25 terabits per second bandwidth in each of those availability zones. So that is how Amazon increases your availability for a particular region. So logically, it will look something like this. The 3 will look like this now. So there is an AZA, and then there is an AZB, and then there is also an AZC. That is, in other words, availability zone A, availability zone B, and C. Inside that, Amazon has built tiny data centers, and all of them are all interlinked together, either with a millisecond. And we talked about the interconnectivity. So Amazon decides the architecture like this, but in a logical, I have to represent the whole infrastructure logically. This is how it will look like. This is the circle, is the whole region, and inside the region you will have separate availability zones, and inside each of those availability zones you will have multiple data centers, and all of these data centers will be connected to each other by using a termination connection. So you will see this TC here. So all of them are talking to each other using this, and this is also duplicated with 2 locations. I mean, two units, let us say, not locations. So there is fault tolerance built here as well. So this is how Amazon achieves high availability. So initially we saw Amazon's presence globally in multiple regions, and under each region you see multiple availability zones, and under each availability zone you see multiple data centers. And let us say that you are using an application which is shared between these 2 data centers. That is, let us have a box here and say that an application is shared between availability zone A and availability zone B, and for some reason you are having an outage in availability zone B, and your applications are not impacted by that outage because your DC, which is in availability zone A, is still able to manage your customer traffic. So you see how easily Amazon has made up high availability. It is very capital intensive, but they have put all that cost there, and they are giving the flexibility to the customers for reaching high availability. So let us go back our map view of things. So this is how you can narrow it down in your mental image. So you have a global data center location, and if I have to take it individually and show it, this is how the region will look like. And region is having multiple ACs, and each of those ACs are connected to the transit points. So this is a logical image, so that you can build high availability architecture. So let us say if your customer comes and says, I'm going to have a web server, build it highly available, and I wanted to put it into Oregon region or somewhere in the West Coast. So you take one particular data center and you put one server in this availability zone and another server in this availability zone. So that way you have a highly available web server, and which is placed in the western coast. So that way you satisfy your customers' requirements. So that is about Amazon regions. We also talked about this high availability using multi-ACs. We touched upon the latency points. We usually have a low latency of less than 1 millisecond. And when you launch an EC2 instance or any particular service, it is you who are going to choose the ACs, whether it is going to be in AC1 or 2 or 3. The choice is absolutely yours. Amazon is not going to force you saying, no, my data center is having a problem, you can put it here only. If it is available in the console, you can go ahead and use it. Absolutely, there are no restrictions. And if you don't want a Western region, for example, let us take a political scenario here. You don't want to host it in a Chinese data center, but you want to distribute content to China, then you use a data center which is nearest to China, say Singapore, and set up Cloud for Front, which is a content distribution network, so that people in China can also see it, but still not host in Chinese data center. So you get all this kind of variety of scenarios in your real life world, and you can satisfy those requirements based on your architecture. So let us look inside an AZ. So we also saw that inside an AZ, it looks like this, multiple data centers, and I'm just representing one of the multiple availability zones that is across the world. This slide is also dated. There are more than 28 now. The reason I keep on saying it is dated is Amazon keeps on adding data centers faster than I can update my slides. They launch at least couple of regions every year, and inside those regions, data centers are additionally added, and it is quite difficult for me to keep track of everything. So the thing that you need to know is always check the Amazon console and find out how many regions are there, whether your customer is going to be put up in the right location, right region, and then you propose the solution. So don't ever imagine that, okay, Amazon is not in Africa, let me not put anything in Africa. So go to the console or go to the Amazon portal and find out if that particular region is there or not, and then make the design decision there. So a simple data center like there is another number is there. Let me show that here. Inside, let us look at now. We saw region and then AC, and inside the AC we saw the data center. Now let us look at inside the data center what happens. So inside a data center, typically Amazon has about close to 50,000 to 80,000 servers. That is quite a large number. This is how Amazon ensures that you have a sufficient capacity, that is compute capacity we are talking about whenever you are trying to launch a server. So typically 50,000 to 80,000 in one data center is a huge number, and think of doing that in all the 4 data centers that is located here. We are talking about literally about 2 lakh servers there, and the bandwidth is about 1 or 2 terabits per second. And Amazon, as noted here, it is multi-ODM source. That means that it is not a single vendor. So if let us say a single vendor is having an hardware 0-day vulnerability, Amazon is not going to be impacted by that because their hardware is completely distributed across multiple vendors, and they have their own network protocol stack. And that is how they reach the logical separation of data, logical separation of your resources. So this is very important. If somebody asks you, this figure is pretty old, and Amazon stopped disclosing how many servers they have in the data center anymore. It might be more than this, or they might optimize it so have with lesser numbers and do the provisioning. So that is about the sample data center, and logically this is how different regions and availability zone looks like. If you take a North Virginia region, I have put 3 availability zones, and if you take an Ireland, you have 3 availability zones, all interlinked and all interconnected. And finally, it is you as a customer, you decide where your applications and your data is going to reside. And I want to bring your special attention to this particular data center, which is called as AWS Government Cloud. This is built mainly with government workloads in mind. For example, in the United States, DARPA and the Pentagon wanted a separate data center for themselves so that they can have additional securities. So Amazon went ahead and created something called government cloud. It is little pricier or little costlier than other data centers or other regions, and it brings in the additional security. Everything here is encrypted. The encryption is not a choice here. Everything by default is encrypted here. So for that additional encryption, Amazon charges a little bit costlier price when you want to put a workload here. Although it says Amazon AWS Government Cloud, you can also put your customers here. That option is available, but the cost is little higher here. So when you're proposing to your client, You can talk about this for additional security and give them confidence that US Defense Department also uses it, but the cost is little bit higher. So, or if you, in other words, if you're working with a government department, you can propose this region as a solution to them. Let's move forward. We talked about security. So this slide, I would like to repeat it because quite often in interviews or any discussion with other cloud service providers, invariably people will tend to ask, how do I put my data into the cloud and how do I secure that? So you need to be really comfortable with the information in this slide and in the next couple of slides. So when you're talking about Amazon Cloud, Amazon takes care of the availability zone security, the regions security, and the edge location security. That is, physically Amazon takes care of the security of the cloud. And in foundation services, if you're using IaaS, that is infrastructure as a service, where you buy only the hardware from Amazon and you host your operating system, the security part of it will go here now because you are hosting the operating system, you are setting up the networks and firewalls. But if you're going to use a PaaS as a service, that is platform as a service, then the compute security will go to Amazon's responsibility. So depending upon what service you choose, the security will be shared between you and Amazon. So always customer data stays here. That is, you are responsible for customer data. That is your data or your customer's data. And if you host any application, your responsibility stays with you. And depending upon whether you choose IaaS or PaaS, that responsibility will also fall to you or to your customer. And here you see the interesting bit, the client-side encryption and data integrity authentication. Say, for example, you want to encrypt your data from on-premises and send it to AWS cloud, then that responsibility also is with you. So likewise, you have server-side encryption and network traffic encryption and all those things. So you choose what you want to do here. And very nice pictorial representation here. Amazon has about 30 global compliance. There was a question here in the chat window. Let me go ahead and read it. You're learning Amazon infrastructure, AWS or platform based. Um, the AWS infrastructure itself is maintained by Amazon. That is the data servers and then the backend network about that and then the connectivity and all those things. Whereas the platform, that is the operating system which is hosted on Amazon, becomes your responsibility. So it is a shared responsibility. That is what I was trying to share here. So going back a little bit. So if the bottom part, the bottom orange box that you see here, this is the physical data center security that we are talking about. The security for the data center, entry and access, how the data is associated, how your server is handled, whether ingress and egress of your data center is authenticated, and who is moving data in and out and all those kind of things. Whereas from your server point of view, it might be a Windows server, it might be a Linux server, it might be an WebLogic application or a Drupal or a Python application. All this are going to be coming into your point of view, that is customer data. It is your responsibility here. It will be stored as customer data and you will also encrypt it from your client side, or you will use server side encryption using the options that is available to you. So it is a combination of both. In other words, you cannot have one without the other when you're talking about AWS cloud and say that I have achieved high security in my data center. So this is a brief about Amazon's security posture, and you can have a small, there is a quote from CIO of Capital One, and which says that we work closely with AWS to develop a security model, and we believe it enables us to operate more securely in the public cloud than we can do in our own data centers. I feel that is a very powerful quote because Capital One is one of the financial institutions, bigger financial institutions in the United States, and if their CIO says that Amazon is more secure than my own data center. That is a very big statement in my opinion. It should be easy to follow that lead and pick up Amazon. So as you can see, they are having military grade security, and the security is available 24/7. And you also have a lot of native tools, or you can bring other third-party tools. And there are tools available in Amazon like CloudWatch and CloudTrail and Cloud Config, which allows you to monitor your account and find out what is happening. You can have alerts or events, event-based alerting that can be possible in AWS. Say, for example, somebody has opened a port from a particular server, and you want to be notified whenever somebody changes your security groups. Then you can trigger a notification to your monitoring team, and from the monitoring team, you can pick it up as an incident or a security incident and try to resolve it. So moving forward, we are a little slow on time. Security tools, as I was saying, these are all the different security tools Amazon provides. When I say Amazon VPC, it is their virtual private cloud, and this tool allows you to logically separate your resources or group your resources, and each of those resources are so isolated that unless you configure an opening, that is a port of egress traffic, nobody can talk to it, including yourself. You cannot connect to that logical separation. So you are giving full flexibility to say who connects to my VPC or who doesn't connect to my VPC. Both whitelisting as well as blacklisting are possible here. And there's a WAF is the web application firewall. So you can have a firewall. Mr. You want to say something? If not, can I request you to go on mute? Okay, thank you. Web application firewall, it allows you to fine-grained access to your application. So login page can be accessed from certain locations only, or your inventory page can be accessed from your corporate data center only, or corporate IPs. Likewise, you decide who accesses what in your data center by using these tools in the networking level. And at the encryption level, you can bring your own keys or Amazon provided keys, or you can have a hardware security module, that is cloud. This is a device that will sit in the Amazon data center and encrypt all your traffic. That is also possible. Or you can combine these two, and that is Amazon provided keys, and encrypt your traffic at a server level and then send it to your customers. So, or you can import your own key into Amazon KMS and use that option also. So both are available. You can use Amazon keys or your own keys. When I say keys, it are nothing but a typical SSL certificates, or you can generate your own certificates and give it to Amazon to manage your traffic between applications. A lot of options are available there for encryption. And identity and access management, this is the user administration part. You have a lot of options here for groups, creating groups, creating users, creating roles and responsibilities. If anybody is familiar with the word of RBAC, role-based access control, then IAM is built specifically for that service, RBAC, role-based access control. And you can also bring your on-premise AD and bring the federated identity management to cloud. This is a little complicated to set up, but it is getting more and more common nowadays because a lot of enterprises have their AD or LDAP systems in on-premises, and they want to use the same thing in the cloud. So that integration is also possible, and SAML-based authentication is also possible. What did I mean is, remember the login with Facebook, login with Google, or login with the Twitter icons all over the internet? Like that, you can also use in your web applications. The SAML-based authentication is nothing but integrating with the third-party identity service providers. So you can do that as well. And the compliance part of it, you have service catalog, meaning what are all the services available to whom, and what services are accessible by whom. So who accesses and how they access it, you can categorize it using Amazon Service Catalog. Cloud Trail, as nothing as this word says, trail, anything that once you enable the service, it is just a checkbox. Once you enable the service, whatever happens to your account, say somebody is requesting for a service, or somebody is deleting a service, or somebody is reconfiguring a service, every API call to your account is tracked. It leaves a trail in your account, and that trail is a trail of logs is stored in multiple locations. So you cannot delete the logs as well directly. If anybody is a Linux user here, you can go and clear your history and command history in Linux very easily by typing history-c. But here the trail is not easy to delete because it is in multiple locations, and you don't have access to the Amazon cloud trail that easily unless you're an administrator or owner of that account. Cloud Config is another service which manages configuration changes. Let us say you have deployed version 1 of an application, and a junior developer comes up and changes the version 1 to version 2 without necessary change control. Then Amazon Cloud Config will notify you of the change and asks you the question of whether you want to revert the change or keep the change. So those kind of configuration management based events can be triggered by using this service. So combining all these together, you achieve a very good security posture in Amazon. Just a look of the certifications. These are all the different certifications. I'm not going to talk about it. If you're familiar, it's good, but just be aware that Amazon has a lot of certifications, and if you want to know more about the certifications, this is the URL, or you can Google it as well. It is aws.amazon.com/compliance. If anybody asks you whether Amazon certifies to HIPAA, you can confidently say it does already, but if you don't know or don't remember, go to this URL and find it more about it. In case if you want to know, HIPAA is here. So moving forward, I just want to touch briefly upon some of the services. This you might have seen already. Let us touch upon in depth. Not in depth, a little bit more in detail. Compute is the server, virtual servers in the cloud. What I mean by virtual servers is typical virtual machines in the cloud. These are all resizable compute capacity. That means you can start with the smallest machine and go all the way higher to a terabyte RAM machine. And the control of these machines are completely in your capacity. That is, you can decide when to move the machine from a lower capacity to higher capacity, and which machine to choose for your workload. And the number says that it's close to 30 plus workload instance types are available. Amazon calls the different types of configurations as instances, and they are all called as instance types. We will look at all these different instance types when we look at the Amazon EC2 classes as a deep dive. For now, you remember the word that Amazon EC2 is the virtual servers, and there are multiple instance types available, and you can choose them based on your requirement. There are compute optimized, that is CPU optimized machines. There are memory optimized machines which start with R, and there are IO optimized machines which start with I. Like that, Amazon has created a lot of configurations, pre-customized machines with a lot of CPU, lot of memory, or some CPU and more memory, or more IO bandwidth and small amount of CPU. So this combinations is available based on your workload. You can choose them. And ignore this point, reduces time to obtain a build a new server, because I will show you practically it takes about only 1 minute to start a server, irrespective of the size of the server. Even if you're starting a machine with, let us say, 100 terabytes or 100 gigabytes of RAM and 20-30 CPUs, it takes about the same minute as much as the smallest server it takes. So there is no absolute difference between starting a big machine to a smaller machine, because all the capacity is already provisioned and it is just available for you to use anytime. And finally, remember that you're paying only for what you're using. Amazon charges, or Amazon billing, is on a per hour basis. What it means is, you start a machine, let us say at 10 o'clock, and you shut it down at 10:30, you will be billed for the whole hour. You will not be billed for the 30 minutes of usage. Or let us take another example now. You start a machine at the morning 10 o'clock, and you stop the machine at afternoon 2:30, then you are going to be billed for the 4.5 hours that you are using. 5 hours that you are using, not for the 4.5 hours that you are using. And likewise, if you shut it down at 2:30 in the afternoon, and you are going to come the next day at start at 10 o'clock in the morning again, the time you have kept it at shutdown state or non-used state, you are not going to be billed for that. So that way your cost comes down considerably. It is not like a traditional data center where you are paying for your power and cooling 24/7. So let's move forward and see what else compute has to offer. Uh, I'll leave the previous slide, or EC2 is the backbone of AWS. I would say autoscaling is the tool or the service which takes AWS forward to the next level, because as you see the arrow mark here, it allows you to go up and down. That means you can go from 10 servers to 100 servers, and once your demand comes down, you can come back to 10 servers again. So it allows you to scale up as well as down with minimal configurations. That is what auto scaling typically does. You can configure it based on CPU, you can configure it based on latency, you can configure it based on a failure event. So there are a lot of flexible options that will available for you. As Amazon says, you can change it based on metrics or health checks, and there is no additional service charges for using this service auto scaling, because it scales the underlying resource. When I say the underlying resource, it is the EC2, it is the scaling, and you are charged for the EC2 instances and not for auto scaling itself. These are all sometimes trick questions that you might expect in the interview, or that whether the auto scaling service is separate, can you use it without using EC2 instances, or can I be billed separately for the auto scaling service? So you need to be clear on what auto scaling does exactly to answer that question. So auto scaling itself is nothing, it's not doing anything great. It just monitors events and reacts based on those events. If there is a failure of one server, it just goes ahead and starts one server again. If the CPU is going to be more than 80% for 10 minutes consistently, then it will start another server. So it actually indirectly starts or stops EC2 instances, and your billing happens for EC2 instances only. And it integrates very nicely with the load balancers. So even if you start 100 or 200 servers, all of them will be put behind a load balancer. So your end user will always have a single point of entry to your application. So that is how high availability is maintained for your application, and fault tolerance is also maintained for your application. So moving forward, there is a serverless architecture is there. It is called Amazon Lambda. Basically, this is a very evolving new field in the compute. There are companies which are using totally Lambda only. They are not using EC2 instances. They are creating servers or applications which respond to events. What I mean by that is, let us say you are uploading a photo to a particular service, and that company wants to create a small thumbnails out of your photos, or want to identify what is inside your photos. Say for example, you upload a selfie, then they want to do facial recognition on that photo and match it or tag it automatically with a certain celebrity or certain person or with your friends, and give a notification saying person A has uploaded a photo, do you want to like it? So all these things are based on the single event that you uploaded a photo, and based on that event you are doing all this downstream processing. So Lambda is a service which perfectly fits into this business case. I gave a simple scenario of a photo upload. You can take it to say for example a media upload. I'm uploading a HD definition video, and Amazon or Google want to convert it into a mobile version or a tablet version or for a low speed internet. So all these things are event based, and the more photo that gets uploaded, Amazon automatically scales the service to do the downstream processing. So it will work very well for a 1 photo upload or a 10,000 photo upload or a 1 million photo upload. So the events trigger the Lambda services, and the Lambda services go ahead and try to run the request and process the request. So if somebody asks you Lambda, you tell them it runs code as a response to events, and that events could be anything that might happen in the cloud. And once again, remember I told you about 1 hour billing for EC2. Lambda is built on seconds. That is the difference between EC2 and Lambda. Lambda is built for the number of seconds you use the compute service. So now we are talking about sub-second billing. So you can run a service for 10 seconds and then be happy about it that you're not using any other cloud resources. So if you have a static website, awesome. And if you have only one form which takes in a photo upload and then that does some downstream processing and you don't do anything else, then Amazon Lambda makes sense for you. You can have an S3 based static website, and the website form which uploads the photo triggers a Lambda event and processes the image there. So you pay only for the S3 hosting and the amount of time that you process the data in Lambda. You are not having a server 24/7 to process your events there. So likewise, you can bring down the cost of using cloud resources. It is highly customized. It requires advanced skills to use this. So that is why the adoption in the market is picking up slowly. There is not a mass scale adoption for serverless architectures right now, but it is good for you guys to know that this is how Lambda services are being used in the market. Moving forward, we have quite a bit to storage. All the great storages are listed here. Let me see if I can talk through them. Amazon S3, Glacier, EBS. Let us look at each one of them in detail now. One moment, guys. Let me have some water. Okay. S3 is their object-based storage in the cloud. What I mean by that is you can store files. The files can be a document file or a HTML file, PHP, CSS, or a photo or a video or a virtual machine image, VDI. That is, you can think of any type of file that you have come across. You can store it in S3. The only disadvantage of S3 is you cannot open a file and modify it and save it. That is block level operations are not possible in S3, but object level operations, that is, you can delete multiple files together, you can upload multiple files. Think of it as a FTP server for easier comparison. It does more than an FTP server, but you can use it for 11 nines of durability. That means that Amazon copies the data all over the data centers, the different data centers we saw in each region, so that it gives you 11 nines of durability, and it is highly scalable. What I mean by that is you are not limited on number of objects that you can store in S3. Typically, Amazon keeps scaling the S3 service as much as data comes in, and the highest single object that you can store scales up to 4 terabytes. To put it in perspective, you can have a single movie file or a text file which is of size 4 terabytes, and you can have multiple 4 terabytes in S3, meaning that you can keep on adding files, and Amazon scales the service on the background. There is no limitation on S3. There is no theoretical limitation on S3 as of now. Very few people hit the service limits, but usually in enterprises that I have worked with, they have not hit the Amazon limits at all. And it is highly reliable because it copies the data multiple locations, so you are sure that your data is available whenever you need it. And it supports both client-side encryption as well as server-side encryption. And client-side is nothing but you send the encrypted data. Amazon doesn't need to know what is inside the data. They don't see your data, unlike Google does. If you put something in Google Drive, Google reads it and tries to sell advertisements based on that. But in Amazon S3, you don't. They don't do that. You can support. It supports encryption fully. After you can send encrypted data, or you can send your data to S3 and then encrypt it also. Both are possible. And once again, you pay only for what you use. I have to repeat it here. The reason is I told you about a 4 terabyte file size. Say, for example, today you are uploading a 4 terabyte file size, and after 1 week you are deleting it. Amazon is going to charge you only for the 1 week of time that you used Amazon services. and you're going to pay for the bandwidth of retrieving the data from Amazon. The ingress traffic is usually free in AWS. That is, uploading is more or less easy. Think of it as a walled garden. Going inside, or a Disneyland, going inside is very easy, but each and every activity that you do there is paid. So likewise, if you want to consume the data from S3, you are going to pay money for that. So that is about S3, object level storage. Let us look at block level storage now. As I said, you cannot do file level that is block level operations, like open a file, modify certain bits of it, and then save it, or have an lock on that file so that other people cannot edit it. These services are not possible in S3. Amazon introduced something called elastic block storage, that is EBS. This is a block level storage Amazon provides, and here all these block level operations are possible. And if you have a database which requires a very highly optimized internal storage, then you are looking at EBS here, because EBS offers persistent off-instance storage. That means that your server is separate and your storage is separate. Even if you stop your server, the storage will have all the data, that is EBS will have all the data that you have configured on top of it, and you can start another server and pick up the data again from their place. And it is you have an option of choosing whether you want to have an SSD based disk or magnetic disk. You have multiple options in each of that. The SSD based disk give you a very high IO performance at a considerably higher cost, whereas the magnetic spinning disks gives you a moderate performance in input and output operations, but at a lower cost. So you need to choose when you want to choose the SSD based disks or magnetic based disks. For example, if your workload is say media streaming, you are running a media streaming company and you want to have a low input output, but you want to lower your cost, then magnetic storage works perfectly for that, because media streaming has the technology called buffering. You are prefetching, so you constantly read data at a constant pace, and then prefetch it, and then send it to the downstream systems or your browser or wherever you're watching your media. So magnetic disks works perfectly for these kind of use cases. When you want to do some in-memory database operations, or big data analytics, or complicated join queries, or SQL queries, then SSD disks performs very well in this area. So depending upon the workload, you choose your disks here. And this is a very interesting point. You can take a snapshot or a backup of your disks and store it in S3. What it means is, S3, we know that it gives you 11 nines of availability. So when you take a backup of EBS and put it into S3, you are getting the same level of durability for your EBS volumes also. And encryption for EBS volumes is just a checkbox away. When you're creating an EBS volume, at the bottom you will have a checkbox, and all you have to do is put a tick mark there and choose the key that will be provided on the right hand side. So if you just put a check mark and choose the type of key that you want to encrypt, whether it is your key or Amazon key, encryption happens automatically in the background. You don't have to do anything to decrypt the data also. Encryption happens so simple, and the performance drop in encryption is also considerably minimal. You don't even notice it that the disk is encrypted and serving you encrypted traffic. Likewise, I already said provisioned IOPS, that goes with very well with this one. You can choose what level of input output operations per second you want for your disk. Based on that, your cost will vary. And here the cost is based on the size that you choose, and the type of disk that you choose, and the amount of IO that you choose. So it is a combination of all these parameters. And once again, you pay only for what you use. If you're using the EBS volume for 1 hour, you're charged for that 1 hour. 30 hours, then it's charged for those 30 hours. Moving forward, let us see what we have today. CloudFront, I keep on talking about distribution networks, and this is the service Amazon uses for content distribution network. The edge locations, this has moved up to 90 now. This 52 is a little bit older. Amazon has moved this number up to 90. Think of it, when I went to Amazon conference in December or somewhere at that time, they said 75, and in June, I went for another conference of Amazon. They said 90. I mean, it is unimaginable the pace that they keep on adding edge locations to the data centers and allow you to distribute content. As the text here says, just another reminder, guys, I don't usually go through the text that is on the screen. I just try to speak it out. If you have any concerns about it, put it in the chat window. I'll try to explain it. But basically, I cover everything that is showed there when I'm speaking about it. So the content is for you to read and keep your attention, basically. That's it. I just want you to focus here. That is why there is a lot of content for you to read while listening to me instead of getting bored. So you can use CloudFront for both static and dynamic content. That means that you can serve HTTP pages or you can serve media streaming websites. Both are possible. And you can also have web forms. You can have inputs like polls that can be happening. You can ask your visitors whether you like the website or not, take that feedback and store it in some location. And it also supports complicated CDN features. Typically, a CDN's quality or compatibility for a particular service depends upon support for some of these features. They want encryption for your content. They want to have geographical restriction. In other words, let us say Game of Thrones is launched in United States first, and they don't want to release it in India. So they want viewers to not view it. So IP-based restriction or a geography-based restriction is possible in CDNs. And you also want to distribute private content. What it means is an enterprise wants to share internal media results or internal financial results with only their own employees. Then you can restrict the data to based on the enterprise-based IPs. So that is also possible so that you can share content between a certain group of people. So before we move on, we are already at the 1 hour window. I am thinking of finishing the storage group. There are a couple of other pieces of data. It might take another 5 minutes. Is it okay with you guys? Since we started 10 minutes late, we can finish up with storage and wind up for the day and come back and continue tomorrow. Quick yes or no in the chat window. Okay, got one answer. Anybody else? Quickly, guys. Okay, great then. I got 3 votes out of many people there. Okay, that is 4, 5. One more will reach quorum. Okay, Srinivas, thank you. You helped us to reach quorum. Moving forward then. Glacier, okay, this service works very well with Amazon S3. Let us say S3 is $2 for storage of a particular gigabyte of storage. Let us put it as $2 per GB per hour. My handwriting is horrible with the mouse. So Amazon Glacier is nothing but $1 per gigabyte per hour. I'm just giving a rough comparison pricing. Amazon Glacier is the long-term archival storage. If you want to have a compliance requirement from financial authority or a payment card industry standards, or some HIPAA requires you to keep it 7 years, I think. Insurance company requires you to keep it something like 7 years. I know very well about the telecom regulations. They expect you to keep the call data records locally for 1 year and in a remote location for 7 years. And HIPAA is far more stringent than that. It must be 10 years. Let us assume that it's X amount of period. So you don't want to keep it in your S3 storage. Let us say this is S3. From S3, you move it into your archival storage. So instead of paying $2 and you pay just $1 in Amazon Glacier. That is what Amazon Glacier is. That is the most important thing that you need to remember. For long-term archival storage, you are going to use Glacier. And for the downside, that is a positive side we talked about, that is the cost. The downside for that is retrieval times are higher. In S3, you can instantly retrieve the data. You can have the URL for the file, you can retrieve it almost instantaneously. There is no delay. The delay might be only on your browser side, on your latency side. But when you want to retrieve from Glacier, it takes about 3 to 4 hours for retrieve the data. You place a request in the console, Amazon tries to retrieve the data and presents you in an S3 bucket. So the positive side is very low cost. The downside is retrieval times. So that is why long-term non-frequent data is stored in Amazon Glacier. And Amazon Glacier also has the same amount of security and same amount of durability. It doesn't have 11 nines of durability. It has something like 4 nines, but that is still good enough for storing it for 10 years. Amazon has some calculation like in these many years, they might lose a file that is like 11 million years or something like that. You can go and Google the calculation. That is not important usually in my opinion. It's just a tidbit or a fact, fun fact. If you want to know, you can Google it and find out. It is very, all we have to remember is it is secure, it allows the encryption, it allows for durability of 11 nines, and there's no limit in the amount of data you want to store there. It is completely flexible. It is, you can use it from the console where you are using your S3. It's just a couple of clicks, you move data from your S3 bucket to your Amazon Glacier. So if anybody asks you, I have some 300 terabytes of data and I want to store it long term, which I'm not going to access frequently at a very low cost, the first service that should come to your mind is Glacier. Definitely some kind of questions like this in the certification exam. They put the 3 or 4 scenarios, and Amazon Glacier is one of those options. Let's move forward and see what else is there. Storage gateway. This is a very, very interesting service Amazon has announced. This service, I would rather go with this text. This is a very nice text to explain this service. It integrates your on-premise IT environments with cloud storage. Typically, you are getting Amazon gives you a virtual machine image that gets installed on your on-premise data center, and through that machine you can configure S3 storage or AWS storage or Glacier storage. In other words, from your on-premises, you can take a backup and store it in the cloud. So think of the flexibility that you get there. If you want to have data moved from your on-premise data center to your cloud, you configure your storage gateway and use S3 as your destination bucket and take a backup and send it there. All your data is already in cloud. Or if you want to use S3 or Glacier, I'm sorry, if you want to use storage gateway as just as a storage itself, then that is also possible. Sometimes in on-premises, I have seen in my experience, scaling your SAN storage takes a lot of time. From the guy who makes a request to the guy who provisions it, it takes about 1 or 2 weeks if you want to add additional 100 GB of data. But once you configure the storage gateway and set up Amazon S3 or EBS volumes as your backend devices, it becomes very, very easy to scale them, because scaling in Amazon is one of the easiest things to do. So using a storage gateway as a storage option for your data center, that is also possible, or you can use it as a backup destination, that is also possible, or you can use it as a migration option. In my projects for migration, I sometimes recommend using storage gateway to move a large amount of complicated data there. When I say large amount of complicated data, this will be small pieces of data distributed all across the corporate data center. I use storage gateway as one entry point or exit point from their data center to Amazon cloud, and I pick it up from S3 and format it or rehost it in the cloud. And the interesting thing is it is available as a iSCSI interface, so it connects with almost most of the existing VMs. Especially it works very nicely with VMware based machines, making migration very, very easy. And this secure transmissions bit, that is dependent upon your VPN, or if you don't have a VPN, storage gateway itself allows you to configure your VPN and secure transmissions between AWS and on-premises. So your data is secure while it is in transit from on-premise to the cloud. That is about Amazon Storage Gateway. Import export options. This is mainly for moving data from your corporate data center to the cloud, mainly for shipping your disks to the cloud. This is for, say, gigabyte of data, and this is for petabytes. This Amazon calls this service as Snowball. If you have petabytes of data on your data center and if you want to move all of them to your cloud, then there is a service called Snowball, Import Export Snowball, and Import Export is the largest brand name. Under that you have something called Snowball. and you ship petabytes of data. Typically, it is a briefcase full of disks. Amazon ships you the briefcase. You connect that briefcase to your data center, copy all the data, and type in your what do I call it is type in your location, your account number, and all those details. Amazon then ships it to the destination and uploads it to the S3 bucket. From there, you can pick it. And this is drive shipping. Typically, you ship your own disks, which is of best for gigabyte scale. But if you have petabyte scale, you need to choose this option. And Amazon has another service called Snowmobile. You can Google that. It is a truck. Yeah, it is a truck. It's a trailer truck. Amazon comes to your data center with a trailer truck with a long fiber channel cable and connect it to your data center, and you can upload all your data to the trailer truck, and Amazon drives it back to their data centers and uploads it. It's a cool service. The truck is pretty white in color. You can Google it. It looks very nice. I have not come across that scenario to use it personally, but Amazon provides you that service as well. And this is another kind of a service which you can use for shipping lot of data, which is mainly for capturing and streaming data. If you have a workload which streams a lot of data, then Kinesis is the option to choose it. But I have not seen many people use this option to upload data into cloud. This is possible only when your data is streamable. In other words, otherwise this kind of service is not useful most of the times. So these are the three options. Direct connect is nothing but your VPN connection between your data center and your cloud. It is typically 1 Gbps or 10 Gbps. So you cannot send a lot of data through this connection. So that is why Amazon came up with this drive shipping, Snowball, and Kinesis to send your data to the cloud. Typically, these are all used for migration purposes, or if you want to upload as fast as possible. There are definitely one or two interview questions and certification questions on import-export options. So you should remember some of these terms. Okay, I guess that brings us to the end of storage services. We will stop here. We will continue on databases and Amazon hands-on console demo tomorrow. Hopefully, I should see everybody tomorrow then. Thank you guys. If you have any questions, I can answer them. I can spend 5 minutes and answer them.